to tell you, here's the current acceleration due to gravity, here's the current acceleration, just tell you over and over and over, and you can set the rate at which that's happening. Much better way to do that, especially since you can have that block be executing on another queue, okay, collecting the data, coalescing it, whatever, and then communicating back to the main queue, maybe at a lower rate where it's updating the UI, okay? So mostly that's what we're going to focus on, is the way of posting a block to a queue, okay? So how do you check the availability? There is this property in CM Motion Manager called accelerometer available, gyro available, magnetometer available, and then the very important device motion available, and we'll talk about that in a second. How do you start up these sensors? If you don't call start accelerometer updates, it will not give you any updates, and when you poll, you won't get any information that's up to date. So you have to start it. Now normally, we're not going to start it this way and poll. We're going to start it by giving it a block to go call us every time, you know, at the whatever rate. So, but we do need to start it. It's important to understand you have to start it. If you don't start it, you get no data. You can also find out, is the hardware currently collecting data? In other words, is the accelerometer on and collecting data? Is the gyro on and collecting data? So you can find out that as well. And very importantly, you can stop it doing this. Why is that important? These things aren't free when it comes to battery, okay? Measuring the acceleration, measuring the gyro position, all that, it takes power. And so you want to turn it off when you're not using it. Just exactly like the CL location manager, right? Turn it off when you're not using it. So here's the polling thing. I have this slide. We're not really going to look at it, but for each of the things, accelerometer, gyro, magnetometer, and device motion, which is the magic one I'm going to talk about in a moment here, you can poll and say, what's the current state of this? But you don't usually do that. And now I'm going to talk about the magic thing before we talk about posting the blocks on the queues, which is CM device motion, all right? If you had a gyro and an accelerometer and a magnetometer, you really know a lot about this device's position, okay? Really a lot. And in fact, you can use multiple of those devices together to get better information. For example, let's talk about acceleration. All right, really, there's an accelerometer in there. It's always measuring the acceleration due to gravity, which is 9.8 meters per second squared. So if you ask the raw accelerometer, what's the current acceleration of this device, it's always going to give you 1g down towards the center of the Earth, okay? No matter what's actually happening. Now, if you are holding a device like this and you're going like this, you're also going to have acceleration in these other axes, but you're still always going to have that one pointing down. So it's kind of like, it's a little bit difficult for you to then figure out what's the user actually doing with my device, you see? Because you kind of have to filter out with like a low-pass filter the acceleration due to gravity. Well, you don't have to do that if you have a gyro. Because if you have a gyro, you know whether device is tilted now, okay? And since you know whether it's tilted, you can factor out where the acceleration due to gravity is, you see? Right? And so CM device motion is another thing you can ask for, just like you can ask for the accelerometer or you can ask for the gyro, you can ask for this magic CM device motion. It's actually a conglomeration of those other things. Okay? And so, for example, it can tell you what is the acceleration of the device with gravity taken out. So there's a property in a CM device motion called user acceleration, which is the acceleration of the device, not including gravity. You can also find out where gravity is pointing based on the device's current orientation. Similarly, there's bias in there for rotation of the device, okay? Bias due to the electronics of the device. That can be taken out using the accelerometer. So the gyro's reported information can also be helped by the accelerometer, so they kind of help each other. And you can also get more sophisticated answers about the position of the device, like roll, pitch, and yaw. Okay? You all know what roll, pitch, and yaw is, right? Roll is this way, yaw is like this, pitch is like this. Okay? So now you really can find out where, like, it's almost like there's an airplane, right? You can find its roll, pitch, and yaw in space, okay? And those are all possible when you know where gravity is, if you know where true north is, you kind of have a reference point, all those things. So CM device motion, that's where you're going to do any sophisticated analysis of the thing's position in space, okay? And you can go look at the documentation. You can see already right there some of the properties you can get, roll, pitch, and yaw, and rotation rate, user acceleration. All those things come out of a CM device motion. Now, if you're on a device that doesn't have a gyro, the CM device motion is going to be there, but some things are going to give you unspecified results, like user acceleration can't be determined on a device where there's no gyro. Okay? It'll give you the acceleration due to gravity, but it can't give you the user acceleration. So you have to know, that's why you have to check what your device has. So how do we do this block thing? Okay, so I want to start my device checking what is going on with the accelerometer, and I want it to report to me what's going on. And the way I do that is I give it a block, a CM accelerometer handler block right there. You can see how it's defined. It takes an argument, which is the CM accelerometer data and an NS error, and it just keeps calling that block over and over at whatever rate you tell it to. And we'll talk about how you set that on the next slide. And you can do that for accelerometer updates. You can do it for gyro updates. You can do it for device motion as well, okay? That roll, pitch, and yaw and all that thing. It'll tell you that, okay? So it couldn't be simpler. You just call this method start accelerometer or gyro updates to Q. You give it a Q. Now, that Q, if your rate at which you're asking it to tell you is pretty low, that could be the main Q. And what do I mean by low? Well, use your best judgment. I mean, 60 times a second, that's going to be pushing the main Q. 10 times a second, no problem. Okay? Some of it depends on what you're doing in that block. Hopefully you're not doing some very, very expensive graphics operation. But you could make that the main queue. Or you could make that be some other queue. Okay? And then coalesce events and then just dispatch back to the main queue whenever you want to do the UI updating. Okay? So how often does this block get called? This is the device motion ones, by the way. Device motion knows so much information, it can actually also have a reference frame about where's the z-axis and the x and y-axis and all that, so you can look that up as well. But this is the same way, though, in terms of you just put a block on a queue, and when device motion has changes, it's going to tell you. So in all these cases, you set the interval at which it's going to call your block using this update interval property. So whether you're doing accelerometer, gyro, magnetometer, device motion, you just set the interval. This is in seconds. So if you wanted 10 times a second, you would say 0.1. If you want 20 times a second, 0.05. Okay? How often can these things go? There are limits. These things can't report 1,000 times a second. Probably you couldn't do much with 1,000 times a second anyway. You couldn't respond in the UI or anything to that. I think most of these things are around 60 hertz, right? 60 times a second, probably about the maximum you're going to get out of them. I don't think the documentation specifically says. It is okay to have multiple handler blocks. In other words, to call start accelerometer updates with block, give it a block, and then later somewhere else, start accelerator updates with block, and give it a different block. And both of those blocks will get called. They're both going to get called at the same rate, this update interval, but you could be doing two different things every time this interval happens. That's perfectly fine. Okay, it's not like there can only be one block. Make sense? All right, so I have a demo. This is all definitely best understood with a demo. And this demo lets me show you a couple other things as well. As usual, I try to make these demos count for multiple things here. So this is going to be a new app we're going to write. It's called Bouncer. And Bouncer is going to be a little square that I'm going to have appear on my device. And eventually, we're going to have gravity determine where that square is animated to on screen. And then we'll put another square on there, and then we'll bang those things into each other, and maybe we'll put a little score in there, and then we've made ourselves a little game. Okay? So it's a little, basically, game where the input to the game is the accelerometer. So I'm going to use the accelerometer because it's the simplest of the device motion things, but they're all basically the same approach of how you get the information back. So we use the accelerometer to drive our UI, just like we touching and swiping, whatever, we're going to use the accelerometer as an input. All right, so let's make a new project here. Whoops, not a new file. Cancel. A new project. Okay, and we're going to call this project Bouncer. And it's going to be universal. I'm also going to do something with this app that I haven't done all quarter, which is I'm not going to do anything in the storyboard. Okay, we're going to do all of this 100% in code, just to see what that looks like. Okay? So I'm not even going to touch my storyboard. All right, in fact, I'm going to move my storyboards down to supporting files because I'm not even going to use them. Okay, it's all going to be in this one file, the entire implementation we're going to do here. All right, so what are we going to do to start? Let's start by just putting a little red square on the screen. So we'll start simple. I'm going to have a little property here, non-atomic strong, which is just a little UI view. I'm going to call it red block. It's going to be a little red square they're going to put on screen. And I'm going to do it, I'm going to put it on screen in view did appear. So once this view appears on screen, then I'm going to put this little block out there. And I'm going to do that in a method called start game, because it's going to be the start of my game. I mean, eventually it's going to be more than just a red block there, so we'll say we're starting our game. So what do we do in start game? I'm just going to say self.redBlock equals. Now, I need to create a block. I want to put it in the center of the screen, so I created a nice little method here called addBlock, this little guy right here. And all it does, as you can see, is it just does init with frame and add subview. And all it's doing is calculating where that frame is. So it's putting it in the center, offset by anything I want, any UI offset. So I'm going to put it initially right in the center. By the way, we don't need this or this for this entire demo. All right, so I'm going to do self add block offset, and I'm going to do UI offset make 0, 0. So it's going to put it right in the center. Okay? Everyone understand what this does? Is just adding a UI view to the center of the screen. And my block is red, so let's make it red. Dot background color equals UI color, red color. Okay, so let's go ahead and run that. Okay. All right, good start. So what we want now is I want some gravity. I want this block to go somewhere else besides in the middle of the screen. So we do that with something you're all very familiar with from assignment 4, which is animators, dynamic animator. So I'm just going to add a dynamic animator here to add gravity and to make it so that when the block gets to the edge, it's going to bounce off, okay, instead of just going off the screen. So let's do that. Since you all know about animator, I'm not going to type all that in. I'll just show it here. This is what I just added right here. Okay, I got some properties. The properties I have here are a dynamic animator, of course. I've got a gravity behavior. That's going to be the gravity pulling on my red block. A collider, that's just going to be the outer edges. That's the only collider I'm going to have for now. And then elastic is an item behavior. I want it to really bounce off the walls. So I'm going to set its elasticity so that it's completely elastic. All of its hitting the walls are elastic collisions. Okay? And so here's the animator, lazy instantiation. Not doing anything special there. Here's the collider. Okay? The only thing that does is translates reference bounds into boundary. Okay? You know about that. Here's gravity, just default gravity. It's going to start out with our gravity pointing down in our view. Okay, wherever down is in our view, in other words, increasing y, that's where gravity is going to start out. We want to replace that gravity with the real gravity of the world. That's what we're going to be doing in a moment. And then here's elastic. Elastic is an item behavior that just sets one thing, which is the elasticity. Okay, this says how elastic the collisions are, and I'm going to have be 1.0, which means fully elastic collisions. You can actually make this greater than 1, and it'll pick up speed when it hits a collision, and you can make it less than 1, and it'll dampen, right, all the way down to 0, which is the default, I think, which is like that's a block, and you hit the bottom, and then just kind of settle real quick.